for actually my stuff here. So I hope you can hear me. So welcome everyone. Is this working? I think it is. Yeah. Okay. On how to lower the costs of your Drupal sites, resources, and capacity planning in advance. First, a little bit about me. I've been working for Acquia since 2011, based in Lisbon. I'm now working with the Site Factory team as a principal site reliability engineer. And also I co-authored that book. It's called Seeking SRE. Also founded the Portuguese Drupal Association. And fun facts, I have 2 kids. They're missing me. And I started using Linux since the 90s. Okay, so today we will talk about the problem we want to solve. Then what is capacity and why plan it in advance? And the relation from SRE and the budget that needs to be presented. Next, we will focus on load testing very briefly and performance tuning and what and how we should measure and how to track that capacity to make some forecasting and then finalizing with some first steps and conclusions, and probably showing very useful tools along the way. So let's start by defining our problem. Maybe I could put this with full screen, right? Yeah, usability problem. So let's start defining this problem. We have a site launch, and we want to keep the user expectation. So anyone here in the process of launching a site or a product? Raise hands. No one is launching sites. Okay, cool. Oh, two people there. Okay, so imagine your customer provide you a set of needs for hardware, and then it sets a date to launch the site, but then he forgot to tell you that he has sent a few thousand emails to Alpha World announcing their new site launch. What do you think it will happen, right? So of course, launching a Drupal site involves a lot more of preparation steps, such as these ones. And there are plenty of guides out there about these kinds of launch readiness checklists for Drupal, which is not our focus today. What we're really missing here on this list is the plan for capacity. So let's be clear. The end goal of capacity planning is a smooth and speedy experience for the users. User expectation may vary depending on what type of application they are using and even what portion of the application they are interacting with. Let's say, for example, the expectations for speed when searching the site for recipes is different from loading the payment page, right? So affecting, obviously, the user engagement. But there is no silver bullet. Let's be honest. It's possible to have plenty of capacity, but a slow website nonetheless, or in the worst case, the service might be unavailable. Even though capacity is only a part of making a good experience, the experience is still one of the real-world metrics that we will want to measure and track in order to make capacity forecasts. For example, when serving static web content, we might reach an intolerable amount of latency in high volumes before any system-level metrics like the CPU, the disk, or memory raise a flag, like in the case of the CDN. So what is capacity? Very simply, capacity consists on the resources required to run your services in the context that you've chosen to run them. Capacity in site reliability engineering is the maximum amount of output your product or your Drupal deployment is capable of completing in a given period of time. Capacity planning, on the other hand, is that process which determines the resources needed. In the Drupal world, we focus mostly on web capacity. So it's used from economics to engineering. It's now also a part of web operations. And it ensures resources are available. It defines the process. It justifies capital needs, which is one of the most important things in our companies. And it's managing deployments of resources. So an extended guide, if you want to really go deep into the subject, is in this book, The Art of Capacity Planning from O'Reilly. So why should we bother about this? Why should you bother about this? So let's suppose I'm a supermarket manager, right? So one of my tasks is to manage the schedule of the cashiers. A challenge for me is finding the right number of cashiers that should be working at any moment. Because if I assign too few, the checkout lines will become long and the customers will be upset. If I assign too many, at the same time, you would end up just wasting up money. So the trick is finding the precise balance. Now, think of the cashiers as servers and the customers as client browsers. Also take into consideration that the supermarket is getting more and more popular each day. So a seasoned manager will attempt to strike a good balance between keeping the customers happy and not spending too much on cashiers. So in summary, only spend as much as you actually need, be ahead of that sharp growth, and avoid any emergencies. And that's also why capacity planning is a major topic in site reliability engineering. Besides that, an SRE team is responsible for the availability, the latency, the performance, efficiency, the change management, the monitoring, the emergency response, and of course, capacity planning for these services. And focusing on demand and forecasting, which is really the important point here, it targets having sufficient capacity and redundancy to serve projected demands with the required availability. Despite this being common sense, of course, everybody knows about this, some service and some teams don't really ensure the required capacity is in place by the time the service is launched. And how does SRE advocate for this? So we help perform regular load testings on the systems. We incorporate SLOs on capacity, which is specific to service level indicators that we have. And because capacity is so critical for availability, SRE teams normally take the lead in this initiative. And so probably one of the biggest part that interests you is the budget related to capacity planning. Your budget should account for enough capacity. It should be justified by the risk of impacting the user experience, as we spoken about, and your business. For example, in the budget meeting with finance, engineering, and product, the proposal for systems capacity needs to be justified by system metrics, right? So we have data to actually justify the investment. But knowing when the infrastructure will fail is crucial to capacity planning. Failure could mean a violation of the service level agreement, the graceful degradation of performance, or even a true failure, like in this case, if that bridge actually goes down. When load testing a Drupal stack, we should document the point of failure as a part of our calculations. However, finding them can be a little bit tricky, and easily segmented architectures help you to find the limits of the current hardware you have in place. You then can use those capacity ceilings as a basis for predicting future growth. To help answer these questions, there are a few tools out there for free, most of them, that you can use for load testing. Keep in mind that we should simulate what will happen exactly if the site is under stress in the future. But you can use tools like the Load Runner, Yago, JMeter, and then collect the results and track the limits with the tools on the right, which are Prometheus, Signal Effects in our case, Cacti, Nagios, etc. And a very important notice, some people confuse these two topics. They are related, but they have completely different goals: capacity planning and performance tuning. Performance tuning optimizes the existing system for better performance, while capacity planning uses the processes like load testing to determine what the system needs and when it needs it, using the current performance, not a better performance, not a futuristic performance as a baseline. So to start a planning for capacity, you must accept that the system current performance is this one, without regard to what you might optimize in the future. For a complex stack like ours, it is important to understand that a single input request to the service will result in multiple inputs across the system. We should always try to split the nodes in components, since that makes it easier to understand the capacity demands of each one. Then you are able to answer a few questions that you couldn't before, but mainly how increasing the request of the queries per second, for example, affects the resources. In the end, after splitting the nodes to a reasonable level in your case, you can identify the key resources that need to be measured, like the disk space, the disk throughput, the CPU performance, the RAM, the network bandwidth, and very important, because IPv4 is just ending in a few weeks, someone told me, yeah, the IP pool. Yeah, it's scary, right? So bad planning of capacity, really, IPv4. Web servers, in this case, they are peak-driven, as you might have noticed in your Drupal sites, and they are application-specific. They accept user requests, they make calls to the backend, and then they use the results of those calls to generate responses. Some applications, like Drupal, they make simple or complex, in the case of Drupal, that's what I mean, queries. Others, they make very simple ones. Okay, so if you don't actually have a way to measure current capacity, you cannot conduct any plan. You should only be guessing. Here is a diagram. It's based on the Brendan Craig site. There was a very nice talk from my friend, Amin, yesterday. Should be published online today, a video about this. And it's talking about several tools that can actually be run in the server to get those measurements. So like in this simple example I scripted, this will always all be available online. There are several ways to collect the measure and the metrics we send to a time series service, like the ones we spoke before. And sending these metrics, for instance, to statsd, can be done with a simple script like this one. And then it can be done also with more sophisticated services like collectd or telegraph, if you need a constant monitoring service. Now we should be able to track the capacity automatically and routinely by measuring system behavior over a predefined amount of time. And by monitoring that normal behavior over days, weeks, and months, you would be able to see some patterns occurring regularly, as well as trends over time that will help predict when you will need more capacity. So to track this capacity, you need tools like to collect and store and display, usually in the graph, metrics over time. A couple of load testing tips. I found some resources online, especially a Docker app that will spawn you Grafana, Graphite, so you can just put that running, collect the metrics, keep them, and then tear it down. And yeah, predicting capacity is an ongoing process. It's not done once. It needs to be based on some intuition and some math to actually make the forecasts. Automating as much as the process as you can will help you to stay ahead of the procurement process. Taking the time to connect the metric collection systems to the trending software. It is possible to predict the future with precision. I'm pretty sure of that now. But it isn't possible. I'm pretty sure of that now. But we can always try our best to forecast capacity using part of context and part of math. It's also a heart of making an educated guess about the future using historical data, like in this case. It's a long-term view. It can be steady. It can be outside of rare bursts and spikes. With all data into perspective, you can generate then estimates to sustain the growth of the website. In the cloud context, these forecasts guide the design of course, the auto-scaling policies. So let's start by taking a look at the daily storage consumption. It's a very easy example. And then you can see a forecast in terms of future needs of the storage. You already know that defining the metric, it's total availability disk space, or total available disk space. So the graphing is cumulative, and its total of this data provides the right perspective from which to predict the future needs. So talking about this graph, it's nearing 30 terabytes, I think. Let me see. And right now, it's currently on 23. So you can see it's going to go over that limit in early April. So this is a very easy situation. But you have the ceilings there. That's what I'm talking about. And you have your historical data, two essential things. So the other thing is you have curve fitting. And this, in capacity planning, this is the most important thing, is where the creative can collide with the scientific. In most cases, it's used to stay ahead of the growth, which is normally seen as the time series data that extends upwards and to the right in some form. Then the challenge is figuring out how and when the data gets there using the forecast. So forecasting is this process that you use for constructing the new data points beyond a set of known data points. The difficulty here with the curve fitting and the forecasts lies on the reconciliation between what we know now and what the data source or the apparent best fit equation is. So simply because you find a curve that's 99.999% effective or has mathematical accuracy, doesn't mean it's going to be like that picture in the future. What about this graph? I'm pretty sure you guys have seen this peak-driven resource usage in any web service. So when we forecast this capacity of a peak-driven resource, we need to track how the peaks are going to change over time. We can then extrapolate from this data and predict the future needs, which is the fun part. The web service metrics here illustrate this process. Then we identify what are the ceilings and define what is the specific CPU usage for this particular hardware. It can also be that the CPU usage is directly correlated to the amounts of work in terms of PHP and Apache, and they are doing this to serve the web pages. And then we can try to find the relation between the system resources statistics and the application level work, which in our case will drive us to a forecasting. So how can we actually automate this? We don't want to be doing this as a manual process over time. So there is a very nice tool. It's called FitYK. It's open source. It's for nonlinear fitting, and we are able to actually automate the process of curve fitting equations to do exactly what we want from the GUI to the CLI, and therefore we can actually script that and automate for our needs. Sorry about that. So in this screencast, what we're looking here, it's running. We have our disk storage. We already had our disk storage example. And then this is the most complex one, which is FitYK trying to actually fit the Apache spikes in our service, and then making an equation there, and then we get that equation and use it for future needs. So forecasting can also be used with machine learning. That's actually one of the things that FitYK is not able to do, but it does the most popular methods, like Levenberg, but you can also use machine learning for this process. There are a few ideas worth exploring in the book I co-authored, specifically on chapter 18. And in this chapter I shared some few code examples of machine learning that you can actually use for forecasting and auto-scaling and several other problems. Please give it a try. So to finalize here, here are a couple of easy steps that will get you started on capacity planning. First, we need to always select a process owner. This would be a person that will be leading the process, and then we need to identify the resources that need to be measured. We need to compare to a maximum of capacity. We need to collect the workload and the forecasts. And then we need to use those forecasts for IT resources and requirements. Then we can map the requirements onto existing utilizations, predict when the system will be out of capacity, and continuously update the utilizations. And most importantly, set a goal. In order to break the constraints of a system and to be effective on capacity planning, defining goals or objectives for your service is very important. And these come from two classes. First is load, usually expressed on arrival rate or peak rate of requests hitting the service. For example, on an e-commerce website, it may target 10,000 of customers making purchases on Christmas. On the second is performance. It's usually expressed in the form of service level objectives for the service. For example, 99th percentile of all requests should return in 500 milliseconds, for example. But mostly identifying why your organization needs capacity and what constraints should it be alleviating is very important, so we can actually avoid bottlenecks of growth. And be proactive. Plan ahead. Document your plan. That's very important. In order to support your decisions of scaling up or down, it's valuable to always have a dashboard with at least these metrics in mind, independently if you are scaling manually or auto-scaling. It should be clear that hardware decisions and things that you need to buy are based on real data. So determine on when to scale and how, like vertically or horizontally or diagonally, should always be supported by numbers. And one of my last tips is to actually take advantage of capacity planning and drive your system to the appropriate level of less risk and the lowest cost. That way, you will ensure an healthy growth while meeting user expectations. Okay, thank you. Any questions? I know it's a hard topic in 20 minutes, and I have a cold, so trying to fight here. No questions. Okay. Okay. Thank you. Bye-bye. Don't forget to actually rate. Thank you.